So we're going to plug in a positive 1. So if I plug in positive 1, I'm going to get 2 plus 4, that's 6. Now I'm going to plug in negative 1. So negative 1 cubed is negative 1 times 2, so negative 2 minus 4, so negative 6 over 2. So the rate of change is going to be 6. Now be careful, we don't have any units. We don't know if this is velocity, we don't know what it is, so we're not going to put any units, we're just going to box 6 and we're done. Now let's do this one. We want to find the average rate of change over this interval for this problem. Okay? I think I might need some more room. Okay. So we're going to do f of 2.5 minus f of 2 all over 2.5 minus 2. If I plug in 2.5, that's going to give me 2.5 squared minus 8 minus, if I plug in 2, well, 2 squared is 4. I get 4 minus 8 all over 0.5. Now here's the thing. On the AP Calculus exam, once you get to a fully numerical answer like this, you can actually leave it as your final answer. It's better to leave the correct answer, even if it's unsimplified, than to simplify incorrectly. Now, if there are little things that you can do, I would appreciate it. So for instance, I would at least simplify this down to like this. I think that's reasonable, and I think most of you can go further. But it's better for you to leave it like this and have it be numerically correct than simplify incorrectly. So that's why on the other key it says you can stop there. If you were to keep going, let's do it real fast. 2.5 squared, I believe, is 6.25. Okay, and 6.25 minus 8 is going to leave me with negative 1.75. Dividing by half is, or dividing by 0.5 is the same as dividing by half. So if I add these together, we're going to get a positive 2.25. Dividing by half is the same as multiplying by 2, so 4.5. Okay. So it'd be nice if you could leave it for me like that, but it's better if you can't do this correctly just to leave it at this point. Again, we don't know what the units are, so we're just going to leave it like that. Number 12, for what value of k is the function continuous at 2? Well, let's ignore this part right here. This is telling me everywhere except for 2, this is my function. We know there's going to be a whole at 2 because this is going to factor to x minus 2, x plus 2, and the x minus 2 factor is going to cancel out. When you have a factor in the numerator and the denominator, that's your whole. So I have a function that probably looks something like this. I don't know, this is going to be rational, so it's going to have, well, no, I guess it's going to end up being linear. So let's say it looks something like this, okay? In order for it to be continuous at this point, we need to figure out what value of y or k is going to fill that hole in. Because if that gets filled in, then I'm going to have a continuous function. Because the only place I have a problem is at 2. So if I can figure out the limit as x approaches 2, that's going to tell me what I'm approaching from both sides. And that's going to tell me the value that I need here. So I'm going to take the limit as x approaches 2 of this. I need to keep my limit notation because I haven't substituted in yet. Now I can substitute in 2, and I get a value of 4. So k is 4. For this problem particularly, because we're solving for k, I probably wouldn't make you justify this with the 3 steps. But if I asked you, is the function continuous at 2, and I had given you 4 here, and you're justifying if it's continuous, then you need to show me those 3 steps. And just in case you've forgotten what those 3 steps are, you're going to start by figuring out what the function value is. Is it defined? Is it not defined? If it's defined, you have to move on to step 2. If it's not defined, it's not going to be continuous, and you stop there. Next, we're going to check the limit. We need to figure out if this exists or not. Remember, function values are defined or undefined. Limits exist or don't exist. If you get values for both of these, you then need to check to see if the value of your function is equal to the limit of the function at that value. Then you're going to write your sentence. F of x is either continuous or discontinuous at x equals, we're just going to say a for now, but you would fill in a value like 2, 3, whatever, because we would either say because if it failed at a step, you'd say because f of a was undefined, because the limit as x approached a of f of x does not exist, because f of a did not equal this, or would be continuous because this did in fact happen. Okay, so let's go to the second side. Find the limit as x approaches 3. Well, as x approaches a value of 3, we're approaching a y value of 0. We're looking for a jump. So this here is a hole. This here is a jump. Because if I filled in this, it would be continuous. But a jump, no matter what, even if this was filled in, I'd have to pick up my pencil. Okay. Now remember, if I said find the points, you would have to give me a y value too. Okay? Find the x values where the function has removable discontinuity. In other words, at the hole. Where's the hole? And the hole is here. Is the function continuous at x equals -2? Show the 3 steps that lead to your answer. At -2. So step 1. What's the function value at -2? Well, the function value is up here. It's 2. The limit as x approaches -2. Oop, the limit doesn't exist. We're approaching something different from the left and from the right. So I can now say f of x is discontinuous at x equals -2, the limit as x approaches -2 of my function does not exist. Now we're going to describe the intervals where the function is continuous. So the places I have to pick up my pencil are here because of the jump and here because of the hole. So the function is continuous all the way up till the jump. I have to use a parenthesis because I don't want to include this point. But then I can start back up there for everything after it until I get to my hole. And then I can start back up after the hole all the way until infinity, as far as we can tell. Okay, I know a lot of people had questions about these problems, and I was talking to some people after school yesterday, and somebody phrased this really well, and they said, when I'm graphing my derivative function, the slopes here become the y values here. So for instance, the slope here might be +5, so my y value here should be +5. My slope here might be +2, so my y value here might be +2. My slope here is 0, so at -1, my slope or my y value has to be 0 because my slopes turn into my y values. Okay. Over here, I'm also going to have a 0 at +1. Okay. Now, what we were doing in class is saying one of the best ways to think about this is figuring out where it's increasing and decreasing the function. That will tell me whether my slope is positive or negative. So I'm going to do that really fast. All the way up until here, my function is increasing. Until here, my function is decreasing. And then again after this, my function is increasing. So what we did in class is we said, okay, let's take f of x. My function is increasing, decreasing, and increasing, which means, oh, I'm sorry, guys, I didn't space this out well. That my derivative function, or my derivative, is going to be positive, negative, and positive. So my slopes are positive. My slopes all through here are negative. My slopes through all of here are positive, which means my y values for all of this over here need to be positive. My slope values, all of these slope values are negative, so my y values should all be negative. My slopes are all positive, so my y values should all be positive. Okay? For some people, like saying, okay, let's find these zeros, these switches, right? So everything here, so this was positive, so all of these points should be positive. From here to here, everything should be below the x-axis. Up here, everything should be above the x-axis again. So if that helps you, you're welcome to use that. I found the number lines to be helpful, but if they're not, it's fine. What you really just need is this graph right here for f prime of x. Make sure you label it, okay? So that's all the problems on here. I hope you guys are feeling good. Make sure you come in ready to go, and I'll see you guys tomorrow. Or I guess if you're watching in the morning, it would be today, but I will see you guys very soon.